Being nice.
I don't know what your position is.
Loving and kindness.
Okay, I like that already. All right, 5-2, dividing polynomials, and there's a picture of bread for some reason. All right. You might encounter compatibility issues. Well, we don't want that. There are two ways to divide polynomials. All right. Cool, long division. I did not make this. I would never make that. But hey, and synthetic division. Yes, cool. All right, let's talk about long division. 5 goes. You have a question?
No, it's not that.
Okay, I know. 6 times. 6 times 5 is 30. In long division, we always subtract. Then we bring down the next one. 5 goes into 46 9 times. That's 45. And in long division, we always subtract. So that's 18. 5 goes into 18 3 times. That's 15. And we bring down the other 3. It's always subtraction. And then 6 times 5 is 30. And we have a remainder of 3. So you can do the really old-fashioned way of remainder of 3. Or you can say 6,936 and 3/5. There's the mixed number. There's your little review of long division. Now we're going to divide this. We're going to do the exact same thing we just did with numbers, and we're going to throw variables in. So x plus 4 divided into 3x squared plus 7x minus 20. We start out with the leading terms, and we just think, well, what do we multiply times x to get 3x squared? First of all, we have to multiply by the 3 to get the 3, but then x times x is x squared. Just like we did before up here. We said, all right, what do we take times 5, not to get 34, but to get as close as we can? Well, 6 times 5 is 30. That's as close as we can get without going over. It's like the Price is Right game. But now we can get exactly what we want. We can get the 3x squared. So 3x times x is the 3x squared. It's exactly what we want. And then whatever happens after that happens. We don't care what happens after that. So 3x times 4 is 12x. We can't match up both of them. We're not trying to. We're only trying to match up the very first one. After that, whatever happens, we're going to deal with it. Now we're going to subtract. That's what you do in long division. You always subtract. Negative 5x is what you get when you subtract. 3x squared minus 3x squared, that's 0. That's why we matched them up, to get 0. And then we're going to bring down the minus 20. Well, now we only look at the leading ones again. We only look at what do we multiply times x to get negative 5x? Well, it's just negative 5. Negative 5 times x is negative 5x. We wanted them to match up. Then whatever happens after that, we don't care. We'll deal with that. We're not trying to match up everything. But in this case, it just happens to match up. So when we subtract, we get a remainder of 0. So the answer is 3x minus 5. Now what does that mean? That's the answer, by the way. But what it really means is 3x squared plus 7x minus 20 factors into x plus 4 times 3x minus 5. So you get 3x squared. Outside is minus 5x plus 12x. That's plus 7x. And then last would be minus 20. So it helps you to be able to factor this stuff, in other words. That's what the long division does for you. But this is the answer right here. 3x minus 5. We're going to try it again, but a little longer one this time. X plus 3. We're dividing that into 3x to the third, 17x squared, minus 21x, minus 11. So what are we going to put first? 3x squared, right? 3x squared. We only care about the first ones. What do we take? Times x to get 3x to the third. 3x squared. So we get 3x to the third when we multiply. And then we just happen to get plus 9x squared. That's okay. We're going to deal with that. We're not trying to match up everything. We're just trying to match up the very first one. We did that. Now when we subtract, we'll deal with what's left over. 17 minus 9 is 8, x squared. Now we're taking these two at a time. So let's bring down the next one. We only deal with the first one. That's it. We just match up the first. What do we take times x? To get 8x squared, we multiply by 8x. That gets us 8x squared. 8x squared, and then plus 24x. We'll deal with that. We're not trying to match up everything, just the first ones. Negative 21 minus 24 is negative 45. Yikes, that got big quick, didn't it? My signs right? I think my signs are right, yep. So minus 45. Negative 45x minus, I think 135. 135. 45 times 3, 135. Now we always subtract. That's going to be negative 11 plus 135. That's 124. So this is 3x squared plus 8x minus 45 plus 124 over x plus 3. It's like the mixed number part. Go ahead and write that down. I'll show you why do we write that. It's exactly the same as your long division with numbers. So I'm going to go quickly. I'm going to go back to the numbers. Look how when we do long division, it's 6,936 and 3 plus 3/5 plus 3 over 5. So now with this one, it's the exact same thing. If you get 124, it's 124 over x plus 3. That's the fractional part. That's where you get your mixed number from. Does it still stay long division? It does. 3x plus 1 divided into 9x to the third minus 18x squared minus x plus 2. Now, we're going to have to deal with the a not being a 1. Now it's a 3. That's okay, because we just think, what do we take times 3x to get 9x to the third? Well, you're going to have to multiply by 3, first of all, to get 9. 3 times 3 is 9. And then x squared times x is x to the third. We get 9x to the third. That's what we needed to do. We needed to match up that first one. Then whatever happens, happens. We have plus 3x squared, and we're subtracting. I got the signs right, yeah. This is going to be negative 21x squared minus x. Negative 18 minus 3, negative 21. Well, now we multiply by negative 7x. Negative 7 times 3, there's your negative 21. X times x is x squared. And then we have minus 7x. And we always subtract. So you distribute that negative 7 through. You match up the very first ones. No, whatever happens, happens. Negative 1 minus negative 7 is 6. It's like negative 1 plus 7. 6x plus 2. Well, we multiply 2 times 3 to get 6. 6x plus 2. And now this time, again, we get a remainder of 0. So that's your answer right here. So this ended up being what we call a factor. When you get an answer, when you get a remainder of 0, this is said to be a perfect, it's a perfect factor. It divides it, very nice. The remainder is 0. That's a factor. This one is not a factor. That x plus 3 does not divide this nicely because there's a rather large remainder. There's a remainder other than 0. That is not a factor. That's the information you can get from long division. Oh, good one. This is going to be a good one. But I don't care if they give us 2 terms or 3 terms or 20 terms. It doesn't matter. The process is exactly the same thing. It doesn't change anything. 3, 2, 1, 0. Look at that. There's a couple things going on in this one. Not only are we dividing by 3 terms, which is a little different, we have a power that is missing. We have a power of 3, a power of 2, but no power of 1. We don't have an x. It goes from an x squared to a constant. They skip over the x. you will want to put the zeros in. If you don't, it's not impossible to do, but close to it. It makes it very difficult if you don't put those zeros in. Now we ask ourselves, what do you take times x squared to get x to the third? We don't care about the rest. We don't care if there's 2 more terms or 5 more terms. It doesn't matter. We take x times x squared to get x to the third. All right, here we go. X times x squared, that's x to the third. X times x is negative x squared. And x times negative 2 is minus 2x. Look at, that's why we needed the 0 there. If we didn't have the 0, where were we going to put the minus 2x? What were we going to match that up with? We got to match it up with something. It has to be 0. So it's like a placeholder. All right, we always subtract in long division. 3 minus negative 1 is 4. 0 minus negative 2 is 2. Then we're taking these 3 at a time, so we bring down the minus 7. So we only have 1 step left. It's only a 2-step problem. That's it. What do we take times x squared to get 4x squared? 4. Then whatever happens after that, we'll deal with it. 4x squared minus 4x minus 8. We always subtract. So we distribute that 4 through. And then we always subtract. Well, we know the first one's going to cancel out. That's how we set it up. 2 minus negative 4 is 6. Negative 7 minus negative 8 is plus 1, right? Negative 7 plus 8, that's 1. The answer is x plus 4. That's the whole number. And then plus, I got to get out of the way, 6x plus 1 over x squared minus x minus 2. That's the fractional part. That's how you do long division. You take that last number and you put it over what you're dividing by. That's the fractional part. Same with variables. Questions? Once you get the process down, this is not that bad. It's just tedious. Definitely tedious. But once you get to the point where you can do this, I don't think it's that bad. Let me give you a head start on this one. Go. Oh, we don't do synthetic at all. Looks like it. The last one. Are there any missing powers? Yeah, the squared, right? Yeah, the squared. The squared is missing. Anybody want to do this on the board? No. No? Nobody? All right, I will.
Oh, wow.
Yeah, Dave can do that. Hopefully it's somewhat obvious why we would put the 0 in, because then what are we going to match up with x squared? We can't take x minus 2x squared. We can't do that. All right, negative 3x to the third. So it looks like this one's going to be about 3 steps long. So minus 3x, right? Negative 3x to the third minus 6x squared plus 3x. Subtract. Always subtract. 2 minus negative 6, that's 8. Minus 2x. Bring down the minus 1. We got one more step. That's what I'm getting anyway. If you think I made a mistake, let me know. Well, we have an 8. So plus 8. 8x squared plus 16x minus 8. We're distributing. And now we have negative 18x. Negative 1 plus 8, that's plus 7. So here's my answer. 2x squared minus 3x plus 8, and then plus, we got negative 18x plus 7 over x squared plus 2x minus 1. There's the fractional part. That's what I got. Hopefully I didn't add wrong. Hopefully I didn't miss a sign. Hopefully I didn't multiply wrong. There's lots of places to make mistakes here. You just have to be very careful with these. Yep.
Did you get the 4x to the 4?
goodness, did I make a mistake right away?
Oh.
Oh, I wrote that, but I ended up being okay. That should be a 2, shouldn't it?
Yeah.
I was thinking ahead before. It ended up being right, but I should have written that. Any other mistakes or problems you see? That's what you got. That's what I got for you. Another